So today, I think I will talk a little about uh, what should it be. Let's see. We have this thing called. Okay, I will talk about uh, this fundamental. One of the fundamental. Uh, what should I say? Forces in our universe. So there are. So if you have two bodies, imagine you anything. You have two objects. One of them can be a car, ball. I don't know, chips packet, whatever you imagine. Another is something else. It can be anything. Chips packet, car, ball. One of them can be an electron. Electron is a very tiny thing. Other can be proton or even photon or whatever. You have two things. Okay, you have two things, anything. So basically from this universe you take anything random, put it on the right side. Take anything random, put it on the left side. So let's say you have one and the other one is two. So if they are separated and let's say nothing is in between them. Okay, nothing is in between them. This is complete space and nothing is in between them. Still, even though in our normal language we say this is not touching this and this is not touching this, but still somehow this thing is making this thing move. One is making two move and two is making one move. And the only way so far we human beings have able to find out how this thing makes this thing move and this thing makes this thing move is by something called a concept of force, some idea called force. And not always force, there is also thing called uh, geometry, whatever. And these are the only things which we know so far, which makes each other which makes things move. So basically you have four things which make other things move. So one of them is gravity, the other one is uh, electromagnetic mag- magnetic force. Another is strong nuclear, and the last one is electroweak. Or let me give a more formal name which I think will be better. So we call this fourth one as weak interaction. It's not exactly completely weak, but we call it weak interaction. It's just some name. So the thing is, uh, now the thing is, so basically, as we discussed before, if you have two objects, anything you take from the universe and place them far apart from each other, the only way one can affect two, like one of the body can affect the other body. Let's call this body 1 and body 2. The only way one can affect 2 and 2 can affect 1 is through these four things. So basically there is our whole universe, our whole everything you can see is inside this thing called field. Inside this thing called field. And what happens is this thing somehow uh, gives information, tells the field that it is there, and this field will tell this other thing that one is there. So basically this is conveying, this is like a messenger between two particles, anything, any two things, and this field makes both of them tell each other that they are there, they exist, and they make each other move. So basically the fields, there are four kinds of fields, or four kinds of things which make other things move. One is gravity, other is electromagnetic, strong and weak. So gravity works in planets. This thing, basically you have seen, like those toy magnets, that is one of the example. And you have when uh, you must have seen something, a kind of a ball, a metallic ball, we call it Van de Graaff, not Van de Graaff, some kind of metallic ball, with when you touch it, when you put your hands on it, your hair start, uh, your hair, like, grow. So not grow, I mean they you know what I'm saying, right? you look you look like you start looking like Einstein if you have long hair. They just keep coming out. So this is also because of this. And this strong nuclear is uh, inside these atoms, these things called atoms, which everything is made of. So atoms, there are nuclear, there are in atom there is nucleus, and in this nucleus you have these small things called proton. This force keeps them together. And finally you have electroweak interaction. This basically makes heavier atoms into lighter atoms. uh, so basically, let's not talk about it. Today I want to talk about this thing, electromagnetic force. Electromagnetic force. So basically, if you have two objects, if the movement between them, like if this is making this move, or this is making this move, by this force. So it is a story of like hundreds of years. We made what should I say, theories. We made a lot of math, a lot of ideas how this will make this move under this regime, this electromagnetic regime. So we call, there are things like charge. So basically, our idea is uh, almost everything in this universe, if it exists, it has some kind of charge in it. Charge. And there are two kinds of charge. One is a negative charge, and other one is a positive charge. These are the rules. So basically, when you have a positive charge and a negative charge, what happens is positive and negative try to come towards each other. And when you have two negative charges, they try to go away from each other. When you have two positive charges, again they try to go away from each other. This is the simple idea. You have two different kinds of charges. If you bring those different kinds together, they will come towards each other, which we call attract. And then this case is a repel, when they try to go away from each other. And now this is the thing. And uh, and we have math for that, like how much will make one move. So basically we have this formula. So this formula, uh, this thing will tell you how much one is going away from the other. This is this tells you the strength. So talking in simple words, the more each of them have the charge, like if this has more and more negative charge, these two will come towards each other more strongly compared to before. Same thing here, if this has more negative charge, they will try to go away from each other. But this idea is still the same. Doesn't matter how much doesn't matter how much negative charge you have, doesn't matter how much ever charge you have. If you have a positive charge here, they will come towards each other. You can't do anything. You can't do anything until and unless you have same charges. You will never be able to repel. This can't change. And same thing for two same charges. If you have two same charges, no matter what you do, you can't make them come towards each other. Doesn't matter how much positive charge you have, they will always go away from each other unless you somehow make one uh, change their charge. Only then it is possible. Other than that, it's not possible. So these are some rules, and perfectly speaking, uh, this one formula will completely tell us how one affects the other. And this is the distance between those two charges. This simple formula just tells you that. And what we did was, this formula was not enough for us. We felt this is very complicated. We even reduced this thing down. We said we want simple things, so we did some very complicated math and brought a simple thing, and this is what we got. So what is simple in this? So you can see there is one. There was square below. There is no more square below now. Okay, that's not simple. But these things vanished. This arrow marks, you can see. This arrow marks just vanished, and believe it or not, but getting rid of arrow marks actually makes your work simple, because you can always get those arrow marks back from this thing. So this is your new result. And then uh, then what we did was, mm, we we like energy, this word called energy, a lot. We we love we are very obsessed with energy, science people. um, Everything we want in terms of energy, and this is in terms of energy. This is not in terms of energy. So energy rocks always. If you if you want to study physics, if you want to understand how nature works in the literature, in the common language, where most of the people trying to understand it using math, then you must be aware of this term called energy. Energy everywhere. No energy, no no subject called physics. Energy, physics, both are uh, impossible to study, to do physics without energy. So this energy uh, tells us a lot about things. So yeah, so the idea is we have to always try finding this thing. For if you have, like, let's say you have some charges, uh, let's say you have a lot of charges, here, charges everywhere. I don't know, it's a mixture, it's a very chaotic thing. Okay, charges overlapping, doing all kind of crazy stuff. But at the end of the day, you will either have a positive charge or a negative charge, and you have a mixture of them. So the total will either be positive, negative, or zero, nothing. And you use this thing called axis to tell exactly where which charge is at what place. And then you basically uh, try to find how much energy is everywhere, and for that you use this wacky formula, very wacky formula. uh, you can even at this point, if you can just quit. I mean, this thing is very weird. It's the worst thing you can see. It sucks too much, honestly. It's the shittiest thing I have seen, but this is what there is, so you have to do this. And so you can see, like, this is worst. Yeah, there, that's it. This is the stupidest thing I can think of, but you have to do this. You have to do all this. So this r is this arrow mark is basically a point, like where exactly, like is it here or here or here. Using this you will tell where it is, and how much it is this much. Yeah, that's how it is. Uh, and physics people like expanding things, so we expand this. We see how it looks, and it looks even shittier. It So first of all, if we write it more, I don't know, um, how should I say, if we try to um, make look things even worse. But I know it doesn't matter uh, how much I criticize it, or how much I bitch cry about it. This stuff is important, because that's all we have. That's the best we can do. I mean, that's the best physics people can do. The smartest uh, people in the world who have done this. All I am doing is just showing you what happened. So something like this it will be. Let me use okay, this maybe put it. So we say, and then we do more math after math, uh, and you might be thinking, what am I doing at this point? But that's how it is. So this is how we write it. And let me do a little computer stuff. I can't do this for longer. So so if I try to write this even more, so let us do a little quick get a help from computer quick. So this thing, so where is my software? We will get help from software. So okay, so I'm just writing some stuff. Mm-hmm. Mm-hmm. I hope this is how it was. And I just do, I will expand this, because that's what physics people do, expanding everything. They love expanding things. this is expanded. Yay. For some reason this is expanded and okay, I think I messed up. Let me fix it. Okay, now I will expand it. Yeah, now this is not messed up anymore, and I don't even want to write this, so I am even lazier. So let me just take a screenshot of this, and I will just cut the part I need. uh, and here we go. I will just paste it up. So whatever I needed is saved. Here it is. So here we go. Let me just put it up here. This ugly looking thing. So here we are, and not to forget that and we can't forget that this thing is also there. So let's write this as well. And by the way, I have to fix things a little more as well. So let me fix things a little more. All that substitutions I had done, I had to. So this is this actually. Same thing here. Okay, let's speed things up. I will just skip this part where I am replacing all the D's. Okay, I successfully changed it, and also this is not dashed, this is not r dash, so I can actually take this outside. So what I mean is I can just put it here, and I will do that. So I can just erase this one. And doing this further, we get this. So this is fixed, and these things I will call I will name them. So let me say p of 0 of a is equal to 1. So this is p0 of a. I will call this p1 of a, and then this thing as p2 of a, p3 of a, okay, not a, cos a, sorry, cos a. And so on. I will compress things down now. I will write it like this. and you have r by r prime to the power of k. Sorry for the disturbance. So this will be, yeah, also summation. This is, there is a summation over k.